Hello, welcome to the channel. Today we are going to learn about Pytorch, and in this video I am going to cover the basics of Pytorch so that for the GPT series I am making it will be more clear what we are doing moving forward. And this is pretty basic, not quite complex compared to other videos I make. Actually, they are quite simple, but yeah, leave that apart. So let's dive through. In this, I'm going to cover things like this. What is PyTorch? Basically, it does the same things as, it does the things similar to NumPy. NumPy is also another library which helps us with complex math operations like differentiation, math, permutations, so on. But PyTorch makes that even more simpler and people most likely prefer PyTorch for this case GPU, and it supports GPU acceleration so that the model can run. Can the model can do stuff simultaneously. If you want to know what GPU is, I generated an AI video for that. You can watch that. I'll attach that in the description. And basically, PyTorch is introduced by Facebook, and it is being used in the GPT models and so on. There are things like what's this stable diffusion, where most of the current image generation is based on, and the direct competitors for these are TensorFlow. This is from Google, and there is another thing called JAX. So from PyTorch, we get support for GPUs, support for automatic differentiation. If you have seen my old videos related to backpropagation, there is so much stuff involved, and PyTorch makes that stuff easy. Supports neural networks. That means neural networks doesn't need that much code, and it is a pretty great abstraction. And here, PyTorch uses tensors. They are pretty much similar to NumPy arrays, but they are particularly made for GPU acceleration. And GPU acceleration, in the sense, we have this thing called CUDA, and compute unified device architecture. Using this, we can switch from CPU to GPU based on the certain task that we have in hand, and this is introduced by NVIDIA, and it is pretty much useful. The configuration for this is quite tough, but here in this video we're not going to cover that. To mm, get a basic understanding of these things, tensors, shapes, basic operations, and the standard thing GPU versus CPU. For this, I'm going to use a Google Colab notebook where I have some code, and using that and using this layer, I'm going to explain what each of them will hold. Tensors. In tensors, we can have scalars, vectors, matrices, and other higher dimension. Like if you don't know what a scalar is something that doesn't have a direction. So it's something like a single number, just to make it simple. And vector has direction and magnitude, so that you know where you are going and what distance you are covering. That will be in two dimensions. The other things are just simple matrix. And so let's dive through this. So basically, these are the things I have explained. First up, we have scalar. and I made a tensor with the number 42. That is the magnitude I'm giving it. And here it will support the shape is nothing but how many dimensions we have for that particular tensor. For scalar it will be like it is one dimensional, and vector will be like two dimensional. And yeah, let's run this. I think I have made a mistake. I'm just typing stuff randomly. See, the torch size is nothing, and this is the zeroth dimension. I'm sorry, I made a mistake. The dimension is zero, and the value we have here for the scalar is 42, just like we initialized. And in 1D, it will be a vector, and I'll give some numbers, and the shape will be it is one dimensional. So this is the thing, and we have the size. It is the length of the array. And in 2D matrix, we'll have rows and columns. The shape will return the number of rows and columns. In this case, we have three rows and three columns. Let's run this. Yeah, here it is. So this is all about tensors. Nothing much to think through. And to create tensors, we have some methods. Some of them will give out zeros. Here I want zeros in the dimension 3 to 4. So there will be three rows and four columns with all filled with zeros. And this is for ones. These are pretty useful. And we can also use a range. I can define the range from 0 to 10 for this tensor, and I can add a step. That means I can skip few numbers in between. Like from 0 to 10, I have added a step, so it will be 0, 2, 4, 6, 8. So basically, we are skipping. The syntax for this is torch dot arrange, and we have identity matrix here. For identity matrix, we'll use the I. If you don't know what an identity matrix is something like this: 1001. If it is like one row, two columns, I mean two rows, two columns. For three dimensional, it will look like this. And the diagonal values, I mean the intersection will be like one always. So this is the identity matrix. For this, we use the I. And the interesting thing about TensorFlow is we can convert it to NumPy and NumPy to TensorFlow again. NumPy basically uses the CPU, and we can generate random tensors either in uniform or normal. Uniform and normal in the sense uniform will be from some range, and normal will be in this bell curve range. These are standard distributions that we need to learn. Yeah, why am adding this? See, we got a range here. Everything will be in a single range, and this is the normal distribution. If we plot these in a graph, we'll get we'll get a clear understanding what these are. And here we have the data types. It will support float 32 bits, float 64 bits. And for to add this data type, you need to do that. You need to use this d type argument torch.float32. It supports int64. And here we can add tensors to true, false, true. And I can also bring in the types of each. We're using the d type again. And we can also do the casting between types. Like I can make the int2 int32, And here we have the basic operations. These are nothing but plus, subtraction, multiplication, division, and these are pretty straightforward. And we can do matrix multiplication. We can use this at the rate symbol or torch.mm matmul. These are the matrix multiplication ones. We pretty much need matrix multiplication to make neural networks, and Pytorch makes that simple. And there are two things too when I'm talking about distribution. There is this thing called rand and random n. N for normal distribution. These are for generating random stuff. We can have this syntax like 32 images of 28 pixels. That will be, I need 32 images of this dimension 28. Here we have this, and this is this random n. I need 32 of matrices of 5 rows and 3 columns. These are for matrix multiplication. And we can also perform the dot product. That means each of them multiplied with the counterpart of the same thing in an index. That is about dot products. And something interesting, if this if we have 3D tensor or 4D. 3D is just batch of matrices, and 4D is CNN. This is mostly used for image classification tasks, all that. CNN means convolutional neural network, where we use this to send inputs of images from one to another. That's a cool thing to learn about. In the coming videos, I'm going to teach about that. And we can just make out some stuff using this PyTorch. You can just reshape it. Let's say I have a 2D thing. I want to make it 3D. Let's say I have an array of numbers like 2, 3, 4. I can make it a matrix like this: 2, 3, 4. That will be like 3 rows and 1 column. That is why we use this reshape, and it is pretty much needed in the back propagation stuff and multiplication stuff, so that we can manage the dimensions between two different parameters. Here I converted it to 3 by 4 matrix, this torch dot arrange. I can bring it back using this -1. It checks the index of it, and I can do the flattening of this. The shape will be written the size of it, and this will give us a good view. And we can also reorder the dimensions using permutations, and after permutations we get these values. And we can also do the transpose. For this you need to use the t. See, this is the image tensor, and you can do the permutation here. And there is this thing called broadcasting. So whenever I initialize a tensor, if I want to make a change to all these, I can just do it in an instant, because each of the values will share it. That's what broadcasting is about. So broadcasting is something like we have a source and multiple other channels will receive the same thing, but the source will be the same. Here I want to add 10 to each of them. We can add 10 to these. That will be like 11, 12, 13, 14, 15, 16. And we can add a row vector too. That means for each row we can add this. Like I want to add these to each row. We can also use the columns, and these are we can also do the speed check, but I haven't added the GPU, so I'm going to skip this part. Anyways, I'm going to share this notebook. Please use your own GPU to check this. And these are some conversions for that, from PyTorch to NumPy, and this is a quick reference guide. These are the most basic stuff we need. In the coming videos, we can check other concepts like the normalization stuff that uh, makes PyTorch powerful. And a very big thank you for watching. This is about PyTorch. I'm going to do other videos too. Please like, share, and subscribe. Your support means a lot. Thank you.